Hey, Mr. Canistero here. I'm here to help you guys out with number 9 and number 10 from the G on an Incline Lab. So, the objectives of this video are to calculate the normal force an incline exerts on a weight, and to calculate the component of the weight which pulls an object down an inclined plane. So the first one pertains to question 9, and the second objective pertains to question 10. So, here's a drawing of the problem. Instead of drawing the sled, I've represented the sled by the square with a mass of 20 kilograms. We also have the angle, 30-degree angle. So what I'm going to go ahead and do is I'm going to first draw a free body diagram to see where we should go from here. So first off, I'm going to draw my weight straight down from the bottom. I label that weight equals mg. Then I'm going to go ahead and draw my normal force from the surface of the box straight up. Label that normal force. I'm also going to draw an arrow going this way because the boy, if you read the problem, was pulling on the sled. So I'm going to draw that. I'm going to label it force of the boy pulling. Now, I started talking about this in class when I was lifting the desk up. I'm going to continue this here. When we have a box on a flat surface, we know the normal force equals mg. But what happens is when you begin to move the box not on a flat surface but on an angle, so for example this inclined plane, the normal force doesn't equal mg. When we talked about in class, the normal force is actually less than mg when you're on an incline. So what we want to do is we want to figure out by how much. So what we're going to do is we're actually going to split this weight equals mg component into two pieces. So what I'm going to do is I'm going to draw these little dotted lines. I'm going to build a triangle. Now if you notice, the line here that I drew is in the same vertical plane as the normal force. So it leads you to believe that if we can figure out what this number is right here, this piece right here, I'm going to label it x, that it's equal and opposite to normal force, and that piece is what's going to be equal to the normal force. Well, using geometry, we can find that this angle is 30 degrees right here. So we have the adjacent side, so that x equals mg, because mg was our hypotenuse, times the cosine of 30 degrees. And since again, it's opposite in direction to the normal force, I'm going to go ahead and tell you the normal force equals mg cosine theta, and in this case, normal force equals m, which was 20 kilograms, times g, times cosine 30 degrees. Awesome, so that's that piece. Now what I want to go ahead and do is I want to calculate the amount, the component of the object's weight, so the component of this weight, which is actually sliding it down the incline. Well, you'll notice when I drew that arrow right here, if I were to go to bring this arrow down this way, you'll notice that it's exactly in the same plane. So it leads me to believe that if I were to find this amount, I'm going to call it y, that would be the amount of the weight that's actually pulling it down the incline. Well, looking at the triangle again, we see it's an opposite to the angle. And again, if mg is our hypotenuse, we know that y equals mg sine of theta. So in this case, the force we're going to call it the sliding force, the amount of the weight that's pulling it down the incline equals 20 kilograms times g times the sine of 30 degrees. All right, well, again, looking back at our objectives, calculate the normal force an incline exerts on a weight. We did that, remember, Fn equals mg cosine 30 degrees. Now we want to do, and we also calculated the component of the weight which pulls an object down an inclined plane. That's force equals mg sine of theta. One last piece that we didn't have was the answer to number 10. Now, in number 10, the question was stated, to determine the force the child is exerting on the sled to keep it from moving down the slope. Well, if we're able to find the force that is pulling the sled down the slope, if the sled's not moving, then we know that the force that he's pulling on has to cancel out. So what you need to do for number 10 is do that mg sine theta to find the amount of force that from the weight that's pulling it down the slope and set that equal to whatever the boy has to pull. All right, well, I hope this helps. Good luck with the rest of the lab.